Hello and welcome. I'm Bill Wake. We're here working on an Elm interpreter. We've been working on expressions for a while, and we're to the point where we want to try our functions out with if statements and recursion. We've mostly got things that accept operators, but the if statement doesn't. In the the condition, if condition, then something else something, the condition isn't ready for operators yet. The then and else clauses are. So we're going to add those. We've already got the operators themselves. We just had to make the grammar accept the full operator expressions. All right, let's go to the IDE. All right. Well, actually, let's run it. So, according to what I remember, if we say k equals 0 and evaluate that, we should get the variable k. And now we can say, does k equal 3? And that should be false. And does k equal 1? Well, that should be, false. Yeah. How about 0? K equals 0 should be true. Okay. So you can see the operator itself works. But if I say if k equals 0, then 1 else 2, that's going to fail. Values are not comparable. And the values it's comparing, I don't know what it's doing really, but it's not parsing the equals 0. It's only looking at the k, and then it's getting confused about what's going on. Okay, so let's see, our to-do. Allow operator expressions on condition of if. Yes, that's right. And let's find our parser. And in effect, what happened is we've made expressions more and more complicated. So originally they were just the very simple ones. Let's see. Here's expression. We'll go there. Okay. So this method was ready to accept int, float, names, parenthesized expressions, lambdas, and ifs, which is all great. But we've added stuff above it. We've added expressions, one or more expressions, which is how function calls look. So if you call function of 3, 4, you call function space 3 space 4. It's a list of expressions. And then beyond that, we have operators. An operator expression is a list of, you start with one expressions, which represents function calls. And then you do a loop while you're looking for operators. So you see function of 3, 4, maybe it's parenthesized, plus 7. Then the operator plus shows up here, gets consumed, and added to the expression, and then the expressions gets consumed. This whole thing is all those expressions get appended together, and then we have the precedence parser that actually interprets them. Because basically, I think what it comes down to is function definitions in Swift and any definitions, in Elm, they look like left-hand side equals right-hand side, but this left-hand side could be some arbitrarily complex thing, and it could be function A, B, C, D, E. You don't know if that's a function call, maybe function already exists, or maybe it's a redefinition, function A, B, C, D, E, and then they type equals and then a bunch of other stuff. All right, so the problem we see then, and I think it was pretty clear in the if statement, I'll get down there again. Okay, we see, we come in here with the if token, we skip over that, and then we have condition equals expression, then a left-hand side is an operator expression, then an else, then a right-hand side is an operator expression. This one's the odd one out. It's just an expression, not an operator expression. So when we go to parse it, it only looks for parenthesized expressions, lowercase names, numbers, and that's about it, lambdas and ifs. So let's write a test. All right, and last time we did the parsing of the right hand side. The this clause, the then clause, the else clause, we made sure they handled operators. Okay, so let's get to the top. Here's a simple if within fixed operators. Okay, and let's do an if with conditions. In fixed operators in the condition. All right, so if 1 equals 2, then 3 else 5. Okay, a little bit nonsensical, but we're only dealing with the parsing, so we want to say this should be rather than the custom value true that used up here, this should be an expression, and it's going to have the same form as this. Okay, function call, and the function is equals, which converts ints to booleans at least. Numeric operator type. Let's see what that. Well, we want a different type. Let's get a comparison operator type. Elm type query. Elm type dot number, and we're taking a little bit of a shortcut here. Elm actually has a more complicated system around equality checks that we're not enforcing yet, and it expects bool type. I don't know if we'll be allowed to do this. Is that gonna work? No. Well, maybe we only need that in the one function so far. Let's just do it down there. No. Okay. So this is comparison operator type. Integer value 1, integer value 2. Yes, if that, it equals integer value 3. Excuse me. And integer value 5. We'll need to close our if expression. Well, he certainly doesn't want this. Let's double check this thing. Condition left, right, and type. Okay, that's what we had. Condition left, right, and type. And the type is the result type, which is the union of these two, or the type union, or however you want to look at that. The enclosing type based on conversion rule, numeric conversion rules, that thing. Okay, that looks okay. So we'll set up this comparison type. If 1 equals 2 should be an if expression. This should be a function call with equals, which is a comparison operator type, values 1 and 2. Okay, and that. I think that looks good. And I just ran all the tests, but we expect it to fail. Yeah. Okay. And the failure. Oh. Interesting. It failed, but it's not telling us what failed. How about up here? Okay. A function called variable equals 1, 2, 3 is not equal to variable equals error missing then or else. Okay. That's a little bit of a weird message. But we'll work with it. And I don't know. We probably want a better we probably wish we'd had a better message. I think when I've taken these shortcuts, I don't know. I haven't been consistent, I think. Hard to believe, right? Okay, so I'm assuming we just plug this in and everything is good. Oh, 2 failures. Okay. Oh, what's the first failure? Something is weird. I upgraded Xcode. Maybe that's my mistake. Let's see this one. If without then fails. Well, I don't know why that would fail. Check failed parse. Missing then or else in column 9 is not equal to 11. Yeah, okay. There's sort of the way the parser's consuming things, I think, can push it off a little bit into a different little position. So let's see what 9 and 11 are in that case. Okay, 1, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's I mean, it's recognizing it at the else. I don't know if I know why that would be. So basically, operator. Oh, yes, I do. Remember, we said we had expressions. So operator expression goes to expressions, which could be function calls. This gets parsed as a function call now, and it's going to fail its type checking on that, but it also fails its parsing on this. So the type checking is a later stage than the parse checking, but it doesn't grammatically. This is legal if you're not applying the semantics that say, hey, true has to be a function and whatever else goes on. So in the old parse, it only looked for one single expression, so it only saw true and it stopped here. But I think this is accurate that should be at 11. Now, the other one is a bigger, more painful feeling. Well, let's double check this. I don't anticipate a problem there. This one is more odd, however. Have I spelled things right? If 1 equals 2, then 3 else 5. Okay. And then up here and check successful. Okay. So the one we quote fixed passed. If function call variable 1, 2, bool 3, 5 is not equal to well, that looks very similar. That's probably a type issue. If function call variable equals 1, 2, bool 3, 5 is not equal to if function call variable equals 1, 2, bool 3, 5. Yeah, that seems okay to me. Well, let's stop here. Let's go in here and get the details on expected and actual. I think it will reveal itself. Partly these dumps of stuff don't include every type of everything. So maybe this Well, yeah, I don't know. We'll see what's different. All right, let's look at actual. Well, printing it may not be the most helpful thing since we already know. Oh, we get the scoop here. Okay. Actual, if expression, his type is number. Condition, custom type bool, values false, true. I'm curious if that matches up. Expressions, 3 values. Type function, generic. Okay. Yeah, we're assuming generic. It probably should be a type int. This is still conditions, expressions. This one's type number, value 1, value 2. Right, so this function is saying I'm generic. My result is bool. And let's look at expected. All right, let's bring this up here. Okay, expected type is number, that's fine. Custom type, yeah, this one is number. Maybe for now, generic is the right type. So, now, see the way Elm really does it, it has a handful of types that are sort of predefined genericizing types or something. I don't know how to best say it, but integers and floats. So there is an int type, there is a float type, and there's a number type. And when an integer gets used mostly, it turns into a number type. It's acceptable as a number. And this lets you mix numbers, lets you mix integers and floating points. Now, once in a while, there's an operator like integer divide that only returns an int type, not a number type. And then you don't get to combine this for free. So it's sort of a mimic of JavaScript's behavior around floats and ints. And I don't know, who am I? Some guy doing this stuff. But to me, that seems like a flaw around the free conversions. I just don't think it would have cost that much to make you do explicit conversions, and it would have simplified that corner of the type system. The second one is there's a type called comparable. And basically, it's, well, I don't know the rules because I haven't found them written down anywhere. But if I compare an int and an int, that should be fine. I think if I compare a number and a float, that should be fine. I can also compare a custom type like booleans and booleans, and that should be fine. But I think you're required that both of the types have to be the same or compatible in some way. But we don't handle comparable. So I think what I'm going to do is bend the type rules a little bit and treat the operators as generics. Now we can go back. Let's find our operators, primitive functions. Let's see what they say. Oops, that's the tests. All right, so we have a Boolean type. There's plus, minus, times, number to number. Floating point divide expects all floats. Integer divide expects all integers. Let's get here. Okay, yeah, here's generic. Now, if I type equals in here, I guess I got to run first. Well, while that's warming up, let's go to the real REPL. Elm REPL. And what's the type of equals? It's going to be comparable to Boolean, I think. A to Boolean. Okay, so it is generic in that sense. Well, maybe we're not too far off. Let's look up Elm comparable. Oh, less than accepts comparable, equals doesn't care. That is really interesting. Unexpected to me. All right, so less than is comparable. Okay, well, I mean, comparable can resolve to certain types. I don't know. I don't know where it documents what they are. Yeah, ints and strings are both comparable. I don't know if floats. Yeah, floats are. Comparables include char, int, string, float, time, or a list or tuple containing comparables. Okay, so that's okay. So comparables a little bit of a, it's got some complexity to it. But this is more generic, right? These are A goes to A is generic, saying any two types. I don't know. Something must. Well, let's look at not equal slash equal. Same. Okay. And less than or equal. Less than equal parenthesis. Okay. So A goes to A says this has to be generic, but once you pick what it is, it should be compatible, same type. So can I say 3.2 equals 4.04? False. Okay. 3.2 equals, let's do 4//2. Force it to be an int. Okay. Yeah. So in there, you can see it's not even accepting int and float, even though most cases it'll let you mix them, at least most arithmetic operators. But in this case, Elm is saying I got a float, I got an int. Those are not, I can't force them to the same type. In this case, it's saying I got a float and a number. I can force numbers to be floats. Okay. So anyway, this is generic. I don't call them A and B. I just call them generic. A goes to A to bool is the same as generic goes to generic goes to bool. Okay, so our test was just wrong about that type. I shouldn't say just. Our test reveals a deep misunderstanding in my interpretation of Elm, is what really has been going on. All right, generic goes to number. All right, this I think should pass. Let's take this breakpoint off. And the thing there is you can't see the function calls type. So when we got the error message, we didn't know what to look for, or didn't pop right out anyway. No, it's still gonna fail. Okay, now we got other things failing. If with infix operators. Okay. This is failing. And lambda. Now, why that would fail, I'm at a loss. Let's pick up this one. No, let's do this one. If with infix It's really, oops, if within fixed operators. Custom value true is Elm type custom type bool. True, true. 1, 2, 2, 5. Number. That seems all right to me. I'm really puzzled though. Like, how does what we did change this? 3.5 function call variable plus 4.5 is not equal to 3.5 function call variable plus 4.5. The lambda ID variable plus 2, 3 is not equal to lambda ID function call variable plus 2, 3 of type number. Oh, golly. I must have done more than I thought. I thought I just changed, well, we did change operator expression. I thought I just changed the test though and added generic on those two. Let's change that back a minute. Okay. Oh, wait. I didn't edit the one I thought I did. Generic Boolean. Okay. What changes have I made then? That one I expected. That's the only change there. That's the one that counts. All right, let's see up here. Yeah, that one's totally wrong. Okay, that explains the others. Numeric. How about number? Number. All right. New function. And adjusted location. Okay, that seems right. See if we get down to 0 failures this time. Build failed. Wow, how many times can I type that rhyme? Type that line wrong, huh? I'm expecting 0 fails. Yeah, all right. Let's see. So what we did was we made if conditions accept operator expressions. All right. So our to-do, allow operator expressions on condition of if. That is correct. 427. Okay. All right. It's a little early, but I'm going to say we need a break. So let's take a couple minutes and be back and see you soon. Welcome back. All right. So we got if operators on conditions of if. Let's give that a run just to make sure we're happy. All right, so if 1 equals 2, then 2 plus 3, else 4 plus 7. We expect 5 to be the result. 1 equals 2. Oh, false, sorry. I meant we expected 11. Okay, so that seems like what we want. All right. Well, I think it's time to go back to that recursion one then. We couldn't write a good recursive function without an if statement that could compare things. So now we have that. Let's work our way towards it. So if I say f of n equals n plus 3, that should be fine. We should handle that very well. Function of 4 is 7. All right, now if I say, let's go to good old factorial. Factorial of n equals, well, if n is 0, then 1, else, let's use double equals, equals 0, then 1, else n times fact n minus 1. Spaces don't matter, just for readability. If n equals 0, then 1, else n times fact of n minus 1. Seems like right off the definition. All right, error. Now, are we hitting this generic thing? N is numeric. Well, no, it's not, right? We don't know what it is really. We know fact of n is, well, the left-hand side is number. The right-hand side, our inferencing is not so good. Fact, well, fact should come up the same as error again. We don't know why. Okay. My suspicion is there's something about the type of fact that it probably is coming back as like generic goes to generic, and then it doesn't know what to do about multiplying a number times a generic. That's my guess. So how can we check that? F of 4, well, how about 3 times f of 2? That is a number. 5 is a number. Okay, well, what makes it hard, right? Something's going on with this. Let's say if n equals 0, then 1, else n times, Okay, let's make n first. N equals 2. If n equals 0, then 1, else n times fact of n. Let's make sure this parsing is... Then else must be compatible. That message could certainly be better. But there's nothing about the definition aspect here. It's all there. All right. So, what we want to happen is it's fine to be generic, but then once we see n times something, we need to say, no, you need to be at least a number type. And then number times number is fine. All right. So I guess this line, oops. Oh. If effective n equals if this then that. Let's try that. I'll call it a parser test, I guess. Function calls. Definitions only have variables on the left. Definition name, definition one argument. No, that's really two arguments. Variable reference. Okay, let's try a definition. Recursive definition. I don't know if it's the recursion that's giving it the problem, but we'll we're going to say fact n equals if n equals 0, then 1 else fact of n minus 1. Okay. And we expect back a definition. Maybe we're not doing symbol tables yet. I think we are. Lambda expression n goes to, well, isn't that going to be fun? If expression, and you may recall that's 4 things. Well, there's the 6 stat. Here's successful parse. Okay. So the if expression, the first argument is the conditional, which is a function call. The function is equals. We'll have to pull that type again. Function call equals, okay. And I think we'll generic and generic returns generic. Maybe we're not doing generic handling quite right. False and n. No, that seems okay. I'll pull this. Function call. This is variable n and integer value 0. Okay. That's the function call. It should equal integer value 1. Else, oh, well, let's call this f function of n function. It's not a real factorial function because we simplified it. Integer value 1, then this is another function call. This is generic. Oh boy. We'll get through the test and then we'll figure out what to do. My mantra. I don't know if that's right. Okay, variable n. Let's simplify further. Let's take out the -1 bit. So I'm mostly trying to figure out, does this thing parse? Okay, lambda expression n, comma, if expression. Okay. If expression function call with comparison, n versus 0. Integer 1, then a function call with variable what does that mean? Well, we don't want equals. We want function. We don't have an integer value, we just have n now. Is that okay? So this closes the function call, this closes that. Now we need, the type should be elm type.numeric number. Boy. It's the if expression, the lambda, the definition, and the check successful parse. Okay. Wow. Function of n equals, if n equals 0, then 1, else function of n. I mean, it would blow up unless n is 0. But does it parse? You're allowed to write horrible code, and the compiler or interpreter has to deal with it. This change in Xcode, I really liked getting my stuff up there. Okay. Definition fact. Well, no, it should be fn. Lambda n is not equal to definition function. Lambda n error, the then and else must be compatible. Okay, we probably have not dealt with generics. Golly. This. Okay, so this should be function, and if in expression variable. We had stuff on generics, right? Maybe it was only operators. Definition with 2 arguments, x and y. Okay. Lambda expression, function call. Is this really the first time we're dealing with that? One problem is I kind of want to cheat for now, and I don't want to deal with the full complexity of generic versus regular type because um, I haven't found a definition of it for Elm. I probably have enough to piece it together, but all right. So function call variable equals n0. That seems okay. Enter value 1. Else function call function of generic operator type with variable n. Now let's find other definitions. Function I don't express anything about his types. That's really odd. Okay. Function definitions near the top. Here we are. Equals, okay. Enforce prototype is all variables. Good. This turns it back into lambda expressions. This turns it into a definition. Where is the type in all this? Right? All right, let's see that error again. It was something about then and else not being compatible. Well, there's A goes to A. Okay. Function lambda n if function call equals n0, boolean 1. Function call function variable n a to a is not equal to lambda n, and then the if got blown up. The if got blown up, must have compatible type. Well, okay. That may be, well, I guess that's on the if statements. Enforce if semantics, let's see what that does. If the condition is not Boolean, then there's an error. If the result type is error, then we get if then else incompatible type. That seems to be what we had. Incompatible type. Yes. Okay. So it is something on the if statement. It's more generic than that, really. Result type is what? It comes in. Left dot type, joint type, right dot type. Okay, that may be. If self is generic, return other. If other is generic, return self. All right, we're gonna jump in on this one. I'm gonna break here. We'll run the test we were on. And it may be somebody's got something that's not a generic type, or maybe I'm just misreading them. Left dot type number. Well, it's already error, so Well, I'm pretty sure that's going to be a problem. Yeah, if anything's an error, bubble up the error. All right, so somehow operator expression has the wrong type. Well, and it's really our function call, right? So let's find expressions. Function call. let's stop here. We have to hit this a few times. Okay. I hate debugging. I would say I used to be pretty darn good at it. I don't know if I am anymore or not, but okay. So let's, I think we're on the first condition. Function n. No, we're not. Okay. Expers.append expression. Okay. Well, what do we have here? We have a generic function applied to a generic n. Okay, so let's look at errors for expers.first. His type is generic. Is it an error? $0. He's not an error. Okay. $1, or next time through, it's not an error. He's generic. Okay. So I'm thinking this is not going to fail. That's both the expressions. Okay. So let's print expers. It's these two. So we're going to have a function call with expers. We'll step in. Function call with expressions. Okay. Function call result type of expressions. Let's step in again. Well, let's see that method. Result type from expressions. Drop the first one. Reduce expressions.first. Let's see what we got. We'll step out. All right, now we can print the type, and it is error. Okay, maybe this function call result type is the problem. All right, let's see. So expressions, we drop the first one. That's the function. And we're left with generic. Okay, yeah, so reduce, remember, takes the first argument, and then it's going to feed that and go from there. So the type is, well, let's make sure drop first does not change the expressions first. Drop first returns the subsequence containing all but the initial elements. Okay, so I think what that's saying then is you're going to go through the second and remaining elements. You're going to take the type of the first, which is generic, which is also kind of like wrong, isn't it? I mean, this function type should be a function type of something to something. So, okay, so I think that's the bottom of the problem. Because when you call it apply, it's looking for a function type, and it wants to apply generic to this function. So if the function were generic goes to int or generic or number or anything, then the function type would be fine. All right, so let's look at apply. Yeah, there we go. If the case is function, if it is a function, then do a joint type kind of thing, with the argument and the the defined parameter and the actual runtime argument. If the joint type is not an error, return it. Otherwise, you got an error. All right, I think that is okay. But function call, I think, I think, no, I think function call is okay too. The problem is, the problem is we don't specify a type on function call. Result type expressions. No, it's that we don't express a type on the function. Because the type of that function should be int. Well, could be generic goes to generic, or generic goes to int, or generic goes to number, but it should be function of something goes to something when you look up function. Oh, man. So where is that going wrong? I think it's going wrong. Well, something here. Function call of expressions. I mean, expressions.first has to be a function type. Otherwise, you've got the true of 42 situation going on. Let's go down. So expressions parsed a lowercase name. Symbol.type for name came back generic. That's the real kicker here. And, well, it's recursive. It kind of has to. Oh, my goodness. Oh, boy. This is a trick. Okay. Let's see if I can articulate what I'm seeing. So the symbol table. So we have the expression function if n equals 0, then something else function of n minus 1, whatever. The reference to function, remember this is all being done at parse time, and the function is in the process of being defined. So there's no function. If we called g and it was already defined, it would not be an issue. But in our case, we're calling function, which we're in the middle of defining, and we don't know its type yet. We know how many arguments it has. Yeah, we could probably do something. I mean, if you've got 3 arguments, we can say you're probably generic goes to generic, something like that. We do convert it to lambdas. Let's go down to the definition, but what happens is when you look up symbol table.type for name, function is not in the dictionary because it's not been defined yet. And all this stuff relies on that. Maybe the moment where we find the equals, we might have to do some work. Yeah, I think that's the deal. So you're going along, you do the operator expression. Where's the equals? Oh, the equals is here. So we've already got name, and we're going to make sure they're all variables. Okay. We got the equals here. Before we do this operator expression, we need to keep track of the type we're creating and give it a generic type. We know the arguments. If it's function ABC equals, then it's got those three arguments and it returns something. I don't think we get voids directly. I'm not sure. You can. There are some times where you see empty parentheses in Elm's code, but I think it can treat that as a result expression, and sort of matching up void to being that. Right. So I think before we go looking things up in the dictionary, we need to make sure they're in there, even if it's very generic, before 107. Okay. Um, right. So can I make a simpler test case? That's always the trick, isn't it? What if? Well, let's duplicate it just because I'm likely to. We'll save that one. Do that later. All right. So what if I just define function of f is function applied to n? Clearly a bit junky, but it's relatively well formed. It's sort of like saying, well, it's sort of like making a recursive function that just returns the function itself, um, or returns f of x equals f of x, right? So it just keeps applying. At runtime, it's a problem. At compile time, it should not be. Okay. So if you do function n equals function n, then you don't have an if expression. You do have lambda n goes to function call. Well, it's more like this one, right? Function call n with variable n, generic, and the Elm type. Lambda expression. What does he take? He takes a name. Excuse me. Lambda expression takes the value and it takes the function definitions. I guess he doesn't take a type here. That's a little weird to me. Okay, lambda expression, definition, check successful parse. Okay. A function of n is a lambda expression. N goes to function call, variable function, generic operator type. And the type of the function is, well, it's really dot function of generic goes to generic. Do I have to say Elm type here? Okay, so we're saying the function type is generic goes to generic because function n is generic on n and returns whatever function of n returns. Okay, so we're going to say generic. And comparison operator type. Yeah, we don't need that thing. Okay, so generic operator function. Let's call it try that. Function n equals function n. Definition function is the same as lambda expression n goes to function call function, generic function type, variable n. All right. I fully expect this to blow up. Whether it blows up the way we're hoping it will, I guess I'm not quite as clear. But I think it's going to struggle around this generic function thing. Turn that off and continue. Well, if it's doing error expression, we know there's a problem. Okay, parser tests. Definition function lambda n function call variable function n colon a generic good is not equal to definition function lambda n function call variable function variable n type error. Okay, that is progress. So we're saying you should be able to look it up and find out that it's generic goes to generic, And this thing is saying, I look it up and I just get an error. All right, so we can stop there and make sure the error is kind of what we expect. Print actual, generic, error. Okay. So what that tells me, and you can see we've been doing this mostly recursive descent parsing, and when you start from the grammar, it looks so clean. Okay, it's just like every non-terminal turns into a function name. So expressions goes to expression plus. Expressions is the non-terminal on the left-hand side. We make a function with that name. Every time it occurs on the right, we call that thing. Okay, so you can see 163 we call expression, and then 166 we call expression. But then we start appending them because we got to keep track of them for semantics. And now we're going to interrupt ourselves in the middle of function definition, wherever that got to. Here. Yeah, so if we see the operator expression, get the left-hand side. If you have an equals, then it's a function definition. Skip over the equals, get the right-hand side, and then everything's busted because this expression referenced this new function that isn't defined yet. So we're going to have to put code here, define it here, okay? And that's, then the definition is there. So when we parse the operator expression, it looks up fn and it says, oh yeah, I see fn. It's generic goes to generic. All right. So this is all under this test we're doing. But I think the thing is that we are coming in with the left-hand side. Coming in here is the list of tokens. Okay, it's all variables. Now we could do this earlier. It just depends how we want to make the semantics go. But if we don't do this, then we have non-variables in there. And when we start trying to calculate their return types, it's going to blow up. So I think I'm going to say this moves up. Okay. And you see it only depends on the left-hand side and equals location, which is here and here. And so there's no harm in that sense. The only thing is we might have a test that was relying on parsing the operators before it called that thing. But let's run all the tests. We expect one failure. The generic function definition thing we're working on. Okay, we'll continue. And keep continuing. Okay, one failure. Yes. And it's the definition thing. Okay, so we didn't break anything with that. Syntactically, it shouldn't matter, but semantically, it does. Okay, so now what we want to do is we want to create a type. Wow, where is that going? Where do the variables look up stuff? I may be getting confused about runtime and interpreting time. Nope, there's symbol table. I believe that's held by this class. Yes. Okay, so we can add things to this symbol table. All right. So what we're going to do is we're going to take the left-hand side and basically we're going to build up a type that's generic goes to generic goes to generic kind of thing. All right, so we need to go Well, if there's more than one, if you just have a function with no definition, x equals 3, there's none of this is going to happen. Oh boy. All right, but if it is a function type, all variables, we would like to know the well, I'm trying to do something about Elm type dot function, Elm type dot generic, Elm type dot generic function, and I wanted to repeat that as many times as I need to. So, well, it's another reduce, right? LHS dot reduce. The first answer is this. And then this is, well, where's our other reduce? Let's get the same words in place. Value and variable. Value is probably fine. It's more like next. Okay, so this is our generic our starting point. And then we want to say value, which is the so far, and next. And actually, I don't even need to do it in something. Okay. I know this is looking like crazy. Value. What's LHS? Oh, it's an expression. Oh dear. Well, that gives me a list of variables. That's all right. Okay, let's go back. Okay, otherwise we got prototype is the thing we can work with. Okay. And we just care how many there are. Okay. So I'm saying the starting point is generic. Generic goes to generic, and then every time you get one, you add it in. Okay. Now, the name is prototype dot first, and the value. Well, this is a weird twist. This is where you fight it every time with recursion when you put it in a language, right? Because we want to say, you can call it, here's its type, you know that, but you don't know what it looks like. All right. Well, symbol table add. That's not good. Symbol table add. XCT issue. No, we want this. Okay. Is the expression. Ah, boy. The thing we want, the thing we care about is the expression has a type. Now, we can about expression itself. I think we can use it. It just, we don't want anybody evaluating it. All right, I don't know. I hope I'm making things better. I'm a little worried my thing is going to be off by 1 or 2 here, but that's okay for now. Let's make an expression, and the type is result type. Okay, so what I'm doing is I'm putting a dummy. Well, I'm trying. String. Okay, first dot name. I'm putting a dummy symbol table entry with the name of the function and its result type, which is function to function to function, or generic to generic to generic. And that's all right. Now, so what I'm hoping that does is it allows the type checking and the parsing to continue. So when you see function of f, function of n equals function of n, you got function with type generic goes to generic in the table. And I think I have to do a drop first here. I'm going to convince myself in a moment, but let's assume that. And do I have to bang? Okay. Because if I have function by itself, I don't want to do any of this. We'll come back to that one. I think we may get an error because if you do x equals 0, you're saying, oh, the type is empty, or its type is generic goes to generic, which is not true for that. We don't really need to do this mess for that. But we are saying for parsing purposes, you should pretend that function is there with the new generic type. All right, let's run it. See how we're doing. I don't think we're done. I think, I got to be hurting things somewhere. Okay, is that the same failure? Okay, recursive definition. All right. And imagine he's coming back with another error. Oh. Interesting. Okay. We are making progress. Variable, we expected generic. Function call type generic. Yeah, let's see what we're getting from when we get here. All right. We've gone a long time. Let's take a break, couple minutes. We'll come back. I feel like we're closing in on something, and we're not quite. It's more complicated than I want it to be, but I think we're closing in on it. So we'll come back and see if we can nail this thing down. All right, 2 or 3 minutes. Hi, welcome back. All right, so, well, as it happens, I'm trying to get this thing balanced out. I think maybe it should start with type generic. Now let's see. My argument is, if you just have x equals 3, then the type is going to be generic. You'll drop the first, and you'll just proclaim it to be generic. That seems right. If you have function of x, then drop first will give us just x. We'll start with generic. We'll wrap it in generic goes to generic. That seems right for a one argument function. Okay, so let's see. I guess I want to run this test, get here, verify that the type is what I want. Let me just run this by directly. Now, with a variable, it's not clear to me that you really should define it first. So that's another issue. But let's see what result type is. Okay, this is function n, so it should be generic goes to generic. Yes. Okay. That seems good. All right, let's continue. Hey, 0 failures. Oh, even a short break helps sometimes. All right, so that says this thing is defined and correct. Now let's try this one again. Generic goes to Boolean. Generic. Okay. Generic operator type. It's really not our function. We decided his type was this. This can be simple recursive definition. That's comparison. This is generic function type. Okay. And we'll maybe grow this. Let's see. So we have function n. If n equals 0, then 1, else function of n. Now this one's slightly less dangerous than the other one because it doesn't blow up unless you call it with anything other than 0. But we'll fill it in with the real thing eventually. Okay, that shouldn't have a green check mark. It never ran. We're gonna hit some breakpoints. We'll turn those off. No breakpoints. Okay, but that one seems good. Okay, let's make it more real. Let's take n times function of n. So instead of function call here, well, it's still a function call. It's, whoops, function call, and it's variable times with well, times has got its own type. Let's see, is it in here? Where do we put that? Primitive functions. I guess we don't have that. Okay. Comparison operator type. There's going to be, oh, we have it up top. Huh. Numeric operator type. All right, so this one is a numeric operator type. That's the variable. Okay. Then we reference n and a function call. I should need another parens here somewhere. And that. Okay, let's format this a little bit more. All right, so the function call variable n, that's, stop. Variable n, that brace goes with that one. That brace goes with that one. I guess we can. Okay. These things get so nested. Oh, goodness. All right. So variable n. Function call goes to variable star that's multiplying n times function of n. Okay. And hopefully ends up in Elm-type.number. I think this might still pass. I mean, I don't think we're introducing any new mechanism. We're double checking our parsing in effect. Nice. Okay, I'm gonna move the simple one up first. And he may be redundant. Because if you can parse the big one, you can parse the little one. Okay, but it gives us a direct proof that the function is there with its generic function type. Yeah, we'll keep it. All right, now I want to do function of n minus 1. So the last n here, this is not a variable. Well, it's a variable inside a function call. Function call, and it takes a variable. Oh wait, I'm messing it up. Okay, let's make sure this passes. Actually, if this passes, I'm going to push it just to, oh, no. Okay, oh, I changed this. And run those tests again. Okay, so let's commit this. We made, in fact, functions. When defining a function, put a dummy prototype in place in the symbol table before parsing the right hand side. This lets the RHS be recursive. All right, I think that is true. Other than this should be recursive. Okay. Now let's do the n minus 1 thing. N minus 1. Okay, so function, instead of calling n, it should call a function call with 2 arguments, well, 3 arguments, variable minus variable n, and integer value 1. Boy. Okay, function call takes that. That matches that one. That matches that one. That matches that one. I mean, these get buried. You got 3 deep function calls here, plus all these others. All right, so function call times n function of minus n1. All right. I hope this passes. I think I've got it all spelled correctly. No. Okay. 180. Definition function n, lambda n. Let's get that there. Can I put this somewhere? Definition, well, basically it's got an error in here. It's not equal to definition. Definition lambda n, if function called variable n equals n0, boolean 1, function called variable star, variable n times function called variable function called variable minus, why is that? No, it's spaced, okay, variable n1 of type number of type generic goes to type number. Something's weird. Surprise. Okay. So function call variable n. I'm looking at the function call variable minus n1. That should be our n minus 1, should be a type number. Yes, that's correct. Then we call a function call with function and that number, and that thing has type A, right? Because A is the result type of the generic function that we stuffed in our dictionary. Generic goes to generic, which comes up as A here. And then the type of this function call times with a generic and a number is number. Okay, if that's the result type we're getting, that's actually correct. Now, what's wrong with this function call? Sorry, parser tests 180. It's like I can't get the types. Very called function, generic function type. Okay, yeah, he gets looked up. No. Function is generic function type. Generic goes to generic. That seems true. Function call. He's called on this thing. Minus n1 should be an integer. And what did I get? I got 3 errors. Error. Huh. And it's expected first. So my expected has errors in it, which is not what I wanted. Not expected. All right. And that may be coming. Why? No, I'm not convinced. I don't think I understand it. All right, we got to go from the inside to the outside. So this thing, minus n1, should come back with type. Oh, I didn't put operator type on this. Numeric operator type. Yes. N1, let's try this again. I don't know if somewhere I'm defaulting types and then just defaults to error. That's probably handy for tests, but not so good for production code. Although this is a test and it doesn't like it. Yeah. Okay. All right. I don't know if copy and paste works across domain lines here, but if I can paste it in my app, I will. Okay, so I paste this. Yes. Function of n equals if n is 0 then 1, else n times function of n minus 1. Evaluate that. If function a goes to number, now we're talking. Function of 2 should be 2. 2 times 1. Function of 3, 6, 4, 24, 5, 1, 20, right? Woohoo! All right. I think we've done it. All right. Let's check this in. Okay. So we finished supporting recursive functions with a definition of factorial to test it. Okay. And that's a pretty complicated test, but we did it. I don't have a good way to make it shorter. I mean, the fact is that an expression of this complexity really is this multiple nested thing. We're trying to check that the parsing produces the nested structure exactly like we want. And I guess we made enough mistakes and saw enough wrong stuff on the way that I'm not convinced that leaving it shorter would be better. I guess our last mistake was this function of n minus 1 not putting the numeric type on there. Yeah, that version with function of n was probably okay, but this one's, a realistic case that you would actually write. All right. So that is checked in. Let's go to do. We don't need this anymore. Okay. Investigate recursive functions. Let's say implement. So this story is kind of like if statement. And the story here is functions should allow recursion. What do we add? A prototype. I'll say function prototype before parsing the right hand side. Okay, that feels like what we did. Let's do some cleanup. Okay. Now, one thing is, boy, this error handling stuff. I'm not so happy about it, I guess. But I can do something here. I think I can. I'd like to extract a method. No, it won't let me. Left-hand side equals location. That seems reasonable. Prototype. Generic value and generic. symbol table.add prototype first name. I don't understand why not. Let's try it manually. Well, I've been putting them below. Enforce function prototype is available. Well, what's going to call that is this thing, which is how about pre-declare function pre-declare function to allow recursion. Paste in this stuff. Ugh. Side effects, yes, I know. Okay, this thing returns. Oh, what does it return? Expression. Well, no, it returns error question mark. Whatever error is. Okay, so if you have an error, it returns it, and otherwise it returns nil. Nil. Okay, we need the LHS and the equals. That is this. LHS and a location. This is just location. Now, see, it's funny. It doesn't seem to have any complaints. We have to do this after it, unfortunately. I feel like I don't know. I heard Go improved their error checking, but whoops. Nope. Okay, I don't know. I worked in Go for a while with before they had exceptions. If they've added that since then, I don't know if they really have. But you ended up writing code like this all the time. Like you had to error check everything in every level, bubbling it up, and all that was just so annoying. And to me, like Swift, I've got the worst of both. Maybe I'd be better off with throws or something like that. But yeah, I don't know. All right, but the point is, this block of code is what I move down into my function down here, and I will make that happen here. I will use prototype. Okay. I'm going to return this same thing. Yeah, boy. Okay, return variable and that. Let's return empty array with this. And then this is prototype and nil. Okay, I don't know. Getting these types right and stuff is just annoying. Okay, so I'm saying let prototype error equal this, which looks a lot like that. I don't know. I mean, is this better? I have to parenthesize that. Yeah. So what I hate is I've got this cost, and maybe I just had to bite the bullet and start declaring throws and deal with it. Maybe that would make it better for people. Then the caller would look for error. But now the caller has to do the same thing. Oh, he gets an error or an exception. Sorry, he gets an error or an actual function call. All right, let's see if this works. My manual extract method. So I kind of followed Martin Fowler's pattern that he describes, where you copy the whole body you're going to do into a new method, go through the body and figure out what parameters you need and what return values you need, and kind of adjust it. And then once you've got everything adjusted, swap it in and see that it works. Okay, and it does. That's good. Right. All right, let's commit this. Refactor extract method for, nope. What name was that silly thing? Enforce functional prototype? No, pre-declare function. Okay. That's okay. Well, given the time, I don't think I want to go too far down the path, but I want to make kind of these three. So this is still on this function call stuff. Consider whether throws would be better than returning the duple. Function definition, enforce, whatever that thing was, pre-declare. And this. Okay. So that'll be a good place to start next time, I think. And we might decide, like the question I would have is, is there any way this stuff could be on like function prototype or function call, or where's the stuff? I guess the deal is we're taking the LHS, it's a function call, and we get the expressions. We make sure they all satisfy that. If not, we return the error, and then we map them into the variables themselves. I mean, it's a bunch of little transformational stuff with an error check in the middle. Like maybe, could function call tell us, I give you an expression, well, let's see, function call, LHS is a function call. Right, so could I give function call a method that is, I don't know, it's gotta do something, like I want it to throw if all satisfy is false. So 150 turns into throw something. And then somewhere above, I have to catch it and say, oh, that's an error expression. Obviously, we should just, it's an error message. Let's return the error expression that corresponds to it, or something like that. Maybe I can't because of the location, but, something. And then all variables, function prototype, all satisfy is variable. See, I'm not sure why 142, 143 is there. If it's not a function call, then it's a list. We're turning it into a list of stuff, just one element list. If it is a function call, we're digging out its expressions. I don't understand why this is there. If it's not a function call, yeah, if it's not a function call, then it was not a list of variables because that would turn into a function call. It could be a single variable. I guess, yeah. That's that ambiguity we have about variables and what's there. But if it's a single variable, you have to be a variable, and you can't be like, you couldn't say 7 equals if true then false or something like that. You need an actual variable there. So we are checking. I mean, the three possibilities is it could be a variable, it could be a function call, which should be a list of variables, the function name followed by its parameters, or it could be any other arbitrary expression. If it's not a function call and it's not a variable, then it's not suitable for a definition. So it should blow up here. I guess that's what's going on. And if any of them is not a variable, then it blows up. Maybe the function prototype, maybe variable and function call can do something similar. I don't know. I'm happier to call a function call method for this specifically. But it would be nice if they could do this. Like I would say, I'm going to give you a list of stuff, and you tell me if they're all variables or not. And if they're not, you throw something back to me. And then I'm going to convert them to variables. Now, why is this necessary? Oh, they are variable question marks. I could probably get them some other way, but yeah, we're basically just converting variable question marks to variables. All right. We will stop here and take this up tomorrow. Tomorrow, 9 to 11:30 a.m. Eastern Time. Thanks for joining me. I hope you can join me again, and have a good evening. Bye-bye.